Okay, so there are four main theories for the origins of life on Earth. Theory number one is God, and that one is a belief system, so it doesn't have any evidence for it and it doesn't have any evidence against it. So two is one called panspermia. And spermia just meaning seed, like some animals do in the sea. They just spread loads of sperm everywhere and hope it lands somewhere. So the theory goes that life might have appeared on Earth. It might have come from, say, if life had started on Mars earlier than it does on Earth, this one would be Mars because Mars is smaller, and then it got knocked off into Earth, maybe. Or that there is life on comets that go around, and that could have brought it to Earth when it crashed as a meteorite. So the main problem with panspermia is it doesn't explain the origins of life. All it does is give you more time, because the thing that because all it's saying is that it must have arrived somewhere, and we don't want to say how, but it started off somewhere else. And what this theory does is allows you to say, okay, well, life appeared on Earth just as soon as there was an opportunity for life to appear on Earth, which is really coincidental, because as far as we're aware, as far as we tell from testing laboratories, making life is really, really hard. So therefore, how it managed to arrive as soon as it was able to, we don't know. But if it had already got a good few rungs up the ladder, and then these microbes live on comets maybe, and then they can arrive to Earth and found somewhere where they could flourish, that would speed up the process. And that's why you have the Mars rover, who is digging and looking for microbes on Mars, and why Europe sent a little satellite called Philander to the comet. And what they're doing is they're digging and they're looking for microbes. So they're not looking for aliens, they're looking for really small bacteria, or even just the environment in which they could survive. That would be handy. Okay. Next one, number three, is one called this one's quite interesting. This one's called electric spark theory. So that pen is not really showing up. Electric spark, and what that's saying is, it's saying that what you had the chemistry of the early atmosphere that was, as we've discussed previously, hydrogen, ammonia, carbon dioxide, and then if you apply a spark, which would have been provided by lightning, then you can create the building blocks of life, and these building blocks of life we give the name amino acid. Now this isn't life. This isn't life. This is the start. This is what life would need in order to come about. Okay, so amino acids, they're the proteins that you could possibly, it's like having a box of Lego, but we haven't made anything yet. That is an amino acid. It's just a piece of Lego, and you could stick it together to make life. Okay. Now there's a problem with this theory, and the problem goes that there wasn't actually enough hydrogen in the early atmosphere to create hydrocarbons, which are the main building blocks of life. That's like your main piece of Lego. So what they're saying now is, well, maybe this could only happen near volcanoes. Because if it was near a volcano, you'd have enough hydrogen. and you'd also have a lot more lightning. Okay, that's the current theory, is that maybe near volcanoes you may have got these conditions. And there was somebody who did a really famous, or two people who did famous experiments on this, and they were Urey and Miller, and they managed to create these amino acids using just these compounds and applying an electric spark across them in the laboratory. So because they were able to do this in the laboratory, it means it's repeatable. Okay, so both of these two we don't have that much evidence for, because we can't create the conditions in which to test it. So these two are really hard to test. I mean, we can go look for microbes on Mars or on comets with Philander and the Mars rover, but even if we found them, it doesn't necessarily tell us that that's how life came to Earth, and even if it did, it doesn't explain how life started. Okay, whereas this one, it is repeatable and it is testable. However, the bit that might not be correct is we don't know exactly what the early atmosphere actually looked like, firstly, and secondly, these are just the building blocks. We don't know how those building blocks were put together. Okay, so next up, 4 is deep sea vents. Okay, deep sea vents. Now these are interesting because we think that the conditions around deep sea vents hasn't changed for millions of years, because, you know, it's so isolated from other ecosystems. So this is where you've got a bit of magma, underwater volcano, but it's got life living in it. Now what we don't know is that life that has gone there since evolving elsewhere, and it's colonised the deep sea vents after life appeared elsewhere on Earth, or did life start in the deep sea vents and then spread out everywhere else? Now you could probably find that by looking at the DNA structure of the animals that live in the volcano, but you know, it's a bit of a chicken and egg problem. Which one came first? You don't know. Although a biologist would definitely know if you ask a biologist. So what they did was, the deep sea vents, they acted like a catalyst, which means that they speeded up the reactions. And because they concentrated all those minerals and gases together, and also so we've had the same conditions for millions of years. So does that mean that we've had that ecosystem for millions of years? We don't know. And the ones that are living there currently, they can live without sunlight, which means they didn't need photosynthesis to get started. Okay, so they didn't need sunlight, which means they didn't need the atmosphere to be, you know how it took ages for the atmosphere to get sorted out. They didn't need the atmosphere to be sorted out. It's just purely the fact that these minerals and gases under the oceans, providing the heat, providing the energy, maybe that's where it started. Okay, we'll never know. One of those 4 is currently the leading one, but I think you can pretty much pick your one out of them. We'll never know. Alright.